All right, let's take a look at another set of properties. Here we're going to take, instead of the product of two exponents, if we take the quotient of two exponents. And really we can build this property from what we just talked about, because if we were taking a to the m times, if we wanted to move this second exponent up to the numerator, move the base up, what would I have to do to its power?
You have to make it negative.
Yeah, so I'd have to make that negative, and now I can use the same rule that we just talked about, multiplying exponents with the same base. We're going to add their powers, so m plus a negative n. Well, that just leads us right to the simple form. When you're dividing two exponents with the same base, you're going to subtract their powers. Okay, so in terms of what you guys are probably the most familiar with is if you're looking at something like this, x to the 7th divided by x squared, most of us probably think of these in terms of just canceling common factors. Two of these x's cancel with two of these, leaving 5. But really what you're doing is this process of taking your common base x, subtracting powers. 7 minus this 2 is equal to 5. And I don't care which way you think of it. If it's easier for you to cancel, that's okay. In addition to this, we also have the property that any number, any non-zero number, taken to the power of 0 is equal to 1. Again, assuming that a does not equal 0 in this case. From the simple perspective, this is pretty easy. So 5 to the 0 has a value of what? 1. When we get to exponents and logs, we'll talk about why this is true. But right now, it's just going to be a rule that we follow. Okay. So this is the simple aspect to it. Well, this does cause some confusion. And the confusion usually comes when there's a negative associated with it. And if I gave you this quantity, negative 5 to the power of 0, is my answer going to be 1 or negative 1? When you look at this, you do have to keep in mind that order of operations is followed with all of these rules. Okay. We always do grouping symbols first, so parentheses first, followed by exponents, then multiplying and dividing, which do not have priority over each other. They're just the same step. Adding and subtracting, once again, neither one has priority over the other. You simply go from left to right if it's both of those. Okay, but parentheses and exponents do have priority over the other groups. So when you look at this, you have a negative 5, which means the opposite of 5, which means 5 times a negative 1. That is multiplication. You also have 5 to the 0 power. That is exponents. So which one are you going to do first? Multiply or exponent? Do the exponent first. So what is 5 to the 0? It's a value of 1. And now you can multiply negative times a 1 gives us our answer, negative 1. So be really careful with the powers of 0, especially when you're dealing with negatives. Now, if this had been negative 5 to the 0 in grouping symbols, now the grouping symbols have priority. So we group it, that whole thing is taken to the 0 power, and again, any non-zero value taken to the power of 0 has a value of 1. So the quantity negative 5, all to the 0 power, does have a value of 1. And so just be really careful that you can distinguish between those differences. And the first one, we're dividing two exponents with the same base, so what are we going to do with their powers? Subtract them. So 6 minus 2 gives us x to the 4th. In the second example, same idea. This time, though, there's positive and negative powers. But we follow the same rule. Same base, a base of t. We're going to subtract powers, so 3 minus a negative 7. Subtracting is equivalent to adding the opposite. So we get 3 plus 7, which is 10. Okay, the third example, again, same idea. We're going to divide exponents with the same base. So we start with our common base, subtract our powers. So negative 5 minus a negative 7. Add the opposite. We get e with a net of 2 for our power. And then the final example, we have division, same exponent's base, so we start with that base, subtract their powers, -2 minus a 2 gives us h to the -4. We could also think of this as moving our h down. We could have also moved our h to the -2 down, changed its sign, and now multiplied across, following the rules for multiplying exponents with the same base. We add their powers. 2 plus 2 is 4. So you could also have 1 over h to the 4th as an alternate form for that exponent.